Okay, so the first thing I'm going to do is create a schematic. So I believe it's this one, schematic layout editor. Um, and this is where, this is kind of like the logical layout. It opened on my second monitor, so I'll drag that over. Get this nice thing. So here's a bunch of details you can fill out if you feel like it. But again, we're not going to do that. And it's kind of like any other layout editor, like a LT Spice kind of. You can actually do your circuits in something like LT Spice and then export the netlist, but we'll get to that. So once again, I'm looking at this and I'm just going to start placing components. And I apologize if I'm a little slow because I haven't done this in a while, but place, power port, and then it gives me this cursor. If I just click, it takes a little bit to load. It only takes this long the first time you load, but it's loading all the different symbols. So these are all different parts. So like you can get FPGA things and stuff.
Yeah, let's see you lay out an FPGA. Do you think you can do that in an hour?
Yeah. I spent a lot of time routing. Yeah, all these microcontrollers. That would be a really fun thing to do, but very much out of the scope of this. Okay, cool. So I'm going to expand power. I'm just going to find ground. I'm going to search for ground here. Ground. Now I have this tiny, tiny ground symbol. And then I'm just going to copy that a few times. So copy, paste. I'm looking at my schematic. It has 4 different grounds here. Don't technically need those. And this is going to be kind of sloppy, but you can spend a lot of time on details, so I'm not going to do that. Place, another symbol. There's probably keyboard shortcuts as well if you're doing this a lot, but I don't think a lot of people do this a lot. I don't think hardly anyone does this a lot. You're working for a company, you probably create a PCB when needed, so it's not like it's what you're doing all the time. So I'm going to look for an audio connector. Let's actually look at this for a little bit, just to get some idea of what the circuit is. So you can't see it. I think I can actually draw on this maybe. Oh, I can. Okay, cool. Oh, I can't control Z though. So you're just gonna have to deal with that. This is a TRS connector, tip ring sleeve connector. So it's a 1/4-inch jack like you'd use on a guitar if you're familiar with that, or any audio application. The tip is the audio signal and the sleeve is the ground. So this sleeve right here is connected to ground. You can't really see it. At least I think that's how the symbol works, and this is the tip. Yeah, so the tip is connected to this transistor. Transistor amplifies and also heavily distorted. If you take micro, you can kind of understand that. And then there's a battery for the bias current through here that provides the biasing. And then you take the output right here. So you have the couple decoupling capacitors, and you can change those. The article that kind of goes over this design has a lot more detail about choices, and he kind of does a comparison of different values, but we'll just do generic capacitors right now. And then, yeah, the focus is the PCB. And then this is a potentiometer right here. So you change that and it changes the gain. And that's also connected to another audio jack. So you can see there's another audio jack here. I wasn't able to find 1/4-inch audio jack footprints or symbols. So when we actually get this printed, we're going to have to do a lot more, maybe even creating a custom symbol, which you can do in here. But for most things, you don't have to do that, or just downloading one from somewhere. So right now I'm just going to use this 2-pole mono. It's tip sleeve. Yeah, there's no ring. So the one that like a headphone jack, it has right, left, and ground, right? But we just have, it's mono, so it's only the tip and the sleeve. So I'm just going to choose that. I'll place that right there. Let me open up my schematic again. And again, it's on my second monitor. Okay, and then I'm going to just copy that over. It'll let me. It's not what I meant to do. Control copy, Control V. And then select it, and hitting R will rotate just like most things. Okay, so this is the input, this is the output. Then I'm going to place battery. I know there's a shortcut, so it's Shift A for this. Search battery. Do single cell. Okay, I'll rotate. Let's place that there. And then I think it's Shift A. Actually, I don't need to keep hitting place because I have the place tool. So if I just click, it'll do it. So resistor. I actually do need one of these. It's not what I was looking for, but I'll take it. A resistor R. So it doesn't matter as much what components you're choosing here in this schematic, like this layout editor. What's going to matter more is the footprints that you assign to these things, because the footprints define like the physical size of the component on the PCB. These are just kind of like a, I don't know, like a logical arrangement of components. So I'm going to place this here. I need a second resistor. No, I don't. I need a capacitor. But yeah, it's pretty repetitive. You're just choosing all your components. One of the reasons we chose a smaller circuit so that I'm not choosing components all day. Control C, Control V. Place that here-ish. All right, now it is just the transistor that's left. And it seems that I lost my tool. Okay, so transistor. Actually, I'm just going to search for 1N, or sorry, 2N. I'm going to choose this one. It's an NPN. He tests a few different ones in the design website or whatever. This is the default one, or the original one. So 3904, place that. Okay, so I can figure out how to zoom. There we go. Now I'm just going to be connecting all these things. So I've been looking at the schematic, and now I just need to place wires. So Shift W is going to do that. So like I said, the tip is the signal. So I'm going to connect this tip to here. This is a decoupling cap, goes into the base of the transistor. And then this is going to go to ground. So it's probably better if I move this ground up here maybe, and then just kind of goofy, but it really doesn't matter what this looks like, because in the end you'll see it just becomes a rat's nest is what they call it. And it's aptly named, I think, but you'll see. And then connect that to ground. Connect this to the resistor on the collector. Connect that to the collector. And this is the output decoupling cap. And that goes to the potentiometer.
Just one quick thing.
Yeah.
On this circuit, you will want, is there a place to put the ground on the sleeve or on the ring of the audio jack?
So these audio jacks only have a slip and sorry, they only have a tip and a sleeve. They don't have a ring.
Yeah, no,
if you had
I got it.
Okay. I think if you had a 3-ring one, you could connect the ring and the sleeve together. Or
no, I'm just talking about like grounding, like the grounds on the guitar to the grounds on the pedal.
Oh yeah, that would be through the sleeve here. I think. I'm pretty sure. Because the sleeve, yeah, so the sleeve on my on my guitar, the sleeve is grounded on the guitar, and then it's also grounded here. So those, yeah, so it'd be the same ground.
Well, if you leave that switch, if you ground it at that point, it'll leave the battery on continuously.
Right, and the battery is just the it provides the bias for the transistor, so it is on all the time. It's just a very low current, and no current's going through the capacitor because it's a decoupling cap. So it's a very small current, so it is using power continuously. You could put like a power switch and disconnect that.
Well, that's what it does if you put the like that external ring, like the red block on the audio jack. If you attach the ground to that, it turns it into a switching jack, so that when you plug your guitar in, and
oh, I see.
it
I see.
starts using the battery. That's
Oh,
what I'm saying.
gotcha. Okay, yeah, I think I've heard of that, but I don't really know exactly how that works. But that makes sense actually. So yeah, that could be a design consideration when we actually get this thing printed. That's a good point. I'm glad you brought that up. I forgot that was a thing, but I faintly remember reading about it somewhere. Okay, so anyway, let's continue here. So connect this to the tip, I believe. Yeah, that should be right. And then this is also going to be connected to ground here. Oh, that is not what I want. I might just copy another ground here. Shift W. Okay. And this ground actually was not needed. I think I just shifted it over here. Okay, so now that's a very crude schematic, but it'll work. You could spend a lot more time on it, but not going to. Yeah.
Was there a diode going from the collector to
Yes,
base?
thank you. There was. There certainly was.
Yeah, otherwise we'd be floating.
Yeah.
Very interesting noise.
Yeah, I don't know what that would do. And it's a 1, and he also tries a few different diodes and even an LED here. Yeah, this is one of the ones. This is going to be interesting. Actually, it's fine. I'll just connect here. Shift W. Connect there. Okay. So yeah, it's pretty gross, not a great layout. And you see all these question marks here on these symbols. You can automatically populate those with this little button. It's just annotate symbols. And it's done. So now you have like C2 and all that stuff. Okay, so now we're gonna export a netlist. So you can do this. You can do this layout with a lot of different editors. Anything that can export a netlist you can do, or you could just write the netlist yourself. It's like you do in labs. Generate the netlist. Yep. Save that here. Okay, so now I'm done in the schematic editor. Actually, no, I need to do footprints. So footprints are what are associated to each of these symbols that are going to be actually printed out on the board. Right now, I'm not going to spend a lot of time choosing each one. In reality, you would make sure that each of the footprints is the right dimension and the holes are the right distance apart for each component. But for now, I'm just going to kind of choose them arbitrarily. It's opening right now. You can't see the loading bar because it's on my second screen. All right, if it'll let me move the window. There we go. It's kind of slow. I didn't anticipate that. Maybe it's because of the video. I don't know. So you can see all the components here on the right side. That's the footprint that's associated with each component. So just going through these, I'm going to choose just a generic. So if I click on battery, it's a footprint library. It had to load all of these. That's probably why it took so long. But and then on the right hand, these are all of the footprints that are in this library. So if I choose a different library, it shows me all the footprints that are in that library. So for the battery one, I'll just, I don't know, zooms in the way. Let's see. You can have battery holders. I don't know. I have no idea what this is, but I'm going to choose it. And then now I'll go down to capacitor, through-hole capacitors probably. And then probably, doesn't really matter. Axial, I believe that's the two wires on it are going to be kind of in line. Correct me if I'm wrong on that, but I believe that's right. And then the radial ones, they're going to be right through the bottom. So like a aluminum, like those tanks, I think. We'll find out. I'll just choose axial here. Or a disc is probably like the ceramic ones with the two ones on the bottom. So probably using ceramic ones for this. So I'll actually just choose these ones. Diode, that's fine. And then see if I can find an audio jack on here.
Skipped it. There was a connector audio up above.
Oh, yep. Thank you. And then probably not surface mount. Oh, I don't know. Horizontal circular holes, very descriptive. I'll just choose the same one for both. And then resistors, it's probably going to be in here somewhere. So this part would actually probably take a decent amount of time. But for now, I'm just choosing random ones. Resistor, axial, I guess. That's a vertical one, so I don't know if you guys have seen vertical resistors, but basically you just stand the resistor on the end and bend one of the what do you call that? Terminals, I guess. Connecting wires, leads, yeah. And so it's like kind of like standing up. I'm going to do horizontal one just because. And then potentiometer. Let me know if you see it. Here we go. 2.5. I don't know what these numbers refer to. I'll just go with this one and see. Okay. And it's not the end of the world. If you choose the wrong one, you can update them afterwards. Apply, save, continue. It's saved. Okay. Okay, now I'm going to go to the actual layout editor. Yeah, so that's this guy. And now it's probably going to load for another minute and a half or so. Or a few seconds. Okay, so this is the layout editor. And I'm going to import that netlist that I generated. Hopefully, since I did this before I associated the footprints, hopefully it still works. I think they're two separate things. So let me open the netlist. Cannot find, oh, missing footprint. Okay, I'm gonna have to re-export the netlist. Apparently the footprints are in that. So
something I do is you could just save this, and then back in the schematic editor, there's a update netlist from schematic or something button.
Gotcha.
So as long as this is saved,
then it's somewhere in here probably.
That one.
Yeah, I'll try it and see what. I don't know, since I never uploaded it in the first place, is it gonna work? Oh yeah.
I have never used the update netlist button.
Oh.
He's got a different method.
Okay. Yeah, I don't know. Oh, okay. I see what you mean. So obviously this is probably the wrong battery holder. It's massive. Maybe not.
It shows a C battery.
Okay, that would make sense. I didn't really pay attention to it. but we'll go with it. I'm gonna rotate this. If I hit M, it selects it so I can move it, and then R rotates, so pretty straightforward. But yeah, this is what I was saying, like the rat's nest, if you have a larger design, it's still all just clumped together like this. All of these white lines are they're basically the how the net is connected. So like this transistor is connected to ground, which is connected to that. So, and if I move this around, you can see that it'll change because there's another ground somewhere else. So it goes to the closest one. So you can kind of see they jump to the nearest one. Yeah. So let me start laying this thing out. I'm just kind of going to go by the schematic again. It jumbles them all up. It doesn't really go with how the schematic is. So this audio jack 2, I believe, is it the input or the output? We'll find out. I'll pretend it's the input and see if I'm wrong. Might be too far out. Oh, I chose like text or something. That's annoying. So this part's a little goofy, but so I'm just selecting things hitting M. Might be better ways to do it. I don't know. Want the diode this way. Probably makes sense for this to be flipped around. Probably doesn't matter. I'm going to put this guy over here. That's interesting. This is connected to, oh yeah, that makes sense. Okay, so this must be, well, there's only one resistor and it's connected to the collector here. So the output cap. This PCB is going to be like 90% battery holder. Okay. This guy. Oh. Okay. And this is the potentiometer, so we probably want it on the edge. So you can rotate it. I'll just put it, whoops. And you could spend a lot of time laying this out to get it just right. Minimize space and distance between components that matter. I'll just move this over here. And yeah, definitely different battery holder, but we'll go with it. All right, so I have these kind of in a layout that makes sense. So now I'm going to start laying out traces. This right here is a trace. Route tracks here. So I'm going to end up using a ground plane. So anything that's connected to ground, I don't necessarily need to lay out a trace for. Actually, I might be able to do the ground plane first. That might make more sense. Let me find the button here. This one, I believe. So it's a filled zone. It's copper filled. So a ground plane is just a plane of copper. You can look that up. And so this is what I want the plane to be associated with. I want it to be connected to ground. I'm going to go with the green one because I like green for ground. So everywhere that there's a ground footprint or pad, it's just going to connect directly to that pad. And then that way, all of my ground connections, I don't have to route traces for. It's just connected to that one plane.
Yeah, Jane, did you want to talk about the difference between the front copper and back copper?
I mean, so it's a two-layer board. So on one side you have front copper, on the other side you have back copper. They're both the same. It's just a layer of copper, but on different sides of the board. So I'm choosing green just because it's ground. It doesn't matter. I like green for ground. Okay. And now I'm just going to trace around the edges of this thing. Probably want to make a square, otherwise whoever's making this thing would not like that. Maybe it makes no difference. I don't know. I didn't click apparently. Yeah, so you can see it's kind of green. You can probably hold shift or maybe control, yeah, and it'll snap it. And then just close it here. Or maybe I just right click and hit close. Yeah, so now you can see like right here, this is ground and there's copper attached to this pad. And all those white lines that were attaching the grounds are now gone because they're attached by the ground plane. Okay, so now I'm going to route the traces and it's going to be on the front copper. And this could really be, I might not even have to use any vias to skip between layers. It looks like there's nothing intersecting, so I can just draw lines between them. On more complicated ones, you'll use what's called a via. So like if you have two traces that are crossing each other, you can use a via to go around it, and there's special considerations for that. Because you don't want to create noise by doing that. But this is easy. I'm just clicking between these. And you can choose different widths for these traces. I'll zoom in so you can see that a little bit. So these are going to be traces of copper on the front layer. This is far from optimized, but it is what it is. Okay, so that's pretty much done. According to who you ask, I should make another filled zone and do a top ground plane. I think it depends on the situation. In this case, I don't think it's going to matter at all. And I don't know the rules for that. Maybe Cody could enlighten us. I don't know. But some people do 2 ground planes, so I'd have the front copper be a ground plane, and then you just have like space between these traces and the other plane.
It's not a bad method, but it's kind of a pain. I mean, this circuit's so simple, you might want to do that.
I'll do it just to show you. So if I add another filled zone.
By the way, the first filled zone was not quite a rectangle.
Yeah, yeah, that looks interesting.
Let's make it a fancy.
Okay, yeah. I'll just confuse the manufacturer. The zoom is very touchy here. Yeah. So if I hit ground here, it's going to create another one on the other side of the board that's also attached to ground. And you can also trim the edges. I forget how, but you can just make these ground planes huge and then cut the edges off.
Yeah, there's an edge cut tool
somewhere.
I think it's the filled zones, and you just choose edge cut.
Over here somewhere.
No, those are just view options. It's on the right hand side. I think it's the same tool you've been using. No, it's graphical lines. So it's just the line tool.
Oh yeah, you can add like a. Yeah, I can't remember how you create a cut though.
It's the line tool right below the keep out zones. It's just a bunch of lines. Yeah, that.
Yeah, I know you can do that, but then how do you say that's my edge? I don't know.
I think as soon as you click, it pulls up a menu.
I kind of feel like I'm just drawing a line on the silk screen.
Nice.
That's okay too. Graphical border just for funsies. Yeah, I don't know. I just drew a line. But yeah, there is a way to cut it. You can just probably Google it.
Is it not in the filled zone options? I feel like that's kind of important.
Add filled zone. Maybe. I'll just do a quick one. Non-copper zone.
Yeah, so there's edge cuts in there. It's one of the yellow ones.
Edge cut, yeah. Okay, there you go. Add an edge cut. Okay, I think it's shift should control makes it straight. That's what I did on the first one, and it didn't end up straight. But okay, I think close on outline. That doesn't seem like what I wanted it to do. Maybe that is what I wanted. Let me deselect edge cut. Yeah, and over here you can deselect lines. So I wanted to see if that rectangle is on a silk screen, but it doesn't look like it.
Yeah, it's just a graphical line.
But yeah, so that's green. Yeah. And you can add like annotations and things and even images. But for now, that's pretty much done. I think that was the correct method for the edge cut. And then you can render it. So we're at 7:44, which is pretty good time. Let me find the render as 3D thing view. So 3D viewer, it'll show you some of these footprints will have 3D models, some of them won't. We're about to find out. Apparently the battery holder does. That's ridiculous. Yeah. Okay. I think ray tracing must be on or something. That's why what's taking so long. If I turn that off, yeah, then it's quicker. So that is the PCB. Footprints aren't right. You'd want capacitors are probably fine, but these are 3.5 millimeter jacks, like a headphone jack, not a 1/4 inch jack. And this battery holder is absolutely ridiculous. And then this potentiometer doesn't have a 3D model, but depends on the potentiometer you have. You choose a different footprint.
It looks like a trimmer too. It's like a little tiny one. I don't know if that's appropriate.
Yeah, it looks pretty small. But yeah, that is in a nutshell KiKad. And then to export, I might need some help from Cody here, remembering how to, it's not going to be in here, but export the Gerber file. I think, let's see, it's probably here.
I think you do it from the project menu, like, you're in the schematic viewer. Like if you back out of this and this schematic editor, like back to the home menu, right here. Yeah, there's a bunch of tools. That's the viewer. I think you select the projects, maybe just the entire project.
This thing.
Otherwise, you could go to the documentation. I mean, that's always a good thing to reference. That's why I don't remember it, because I always just read the document.
Yeah, KiKad export Gerber. It's not even really their documentation. Maybe it will be. Who knows?
I always use it. I mean, because this is the manufacturer we've used. They have good.
Yeah. Generate drill and Gerber files, file plot, and so that's in. That's here. PCB new file plot. So let's see. And what options did they say to do?
Yeah, and it's important. This website is the manufacturer that you'd be using. You want to use what they recommend. They have some specific things they're recommending as a manufacturer.
Yeah.
Because this is the instructions to make the board. So.
Yeah, I'm just gonna for now just generate.
Yeah.
So it's been forever, and it's already generated. So that's just the drill file. I also want to generate the map file, which is, I believe.
Yeah, that's right. You gotta do both.
Yeah.
The drill file is just where all the holes go, obviously. The map is the layout of the other components.
Yeah. And then you'd upload that to the manufacturer. I really need to go to the bathroom. So if maybe Cody can talk more about that, or maybe share your screen and show the manufacturer's page even.
Okay. Yeah, that might be more productive.
Yeah. And then you can just kind of see.
I was thinking you can give him control to your computer, and then he can still show it.
Or if you want to do that, it's not
That's
hard
cool.
to up.
Yeah, just give him control. Here you go.
Mike's about to fall off. All right, I'll be back, but I will turn it over to Cody.
Okay. Sharing screen. What is the KiKad website? So yeah, the manufacturer we've used in the past with good luck is JLC PCB. Pretty affordable. It's really easy to work with. Essentially, you select a 2-layer PCB. When you upload a Gerber file, it will automatically fill in things like the dimensions. The minimum quantity is 5. It's $2 for 5 of them. I think that might be a promotional offer for the beginning, but they're really, really cheap. So everyone that I've talked to, and I've felt this way before, like I wanted to make my own printed circuit boards and go get some acid to etch the copper and buy some blank boards, but it's like, it's so much tooling and it's so much work to make the solder mask, the etching mask, that it's really not worth it. They're so cheap these days. That's why learning how to do this is awesome, because I don't know, a lot of you have probably done circuits on like perf boards, and that is just super tedious, making all the interconnections and everything. It's a good way to like prototype and try some stuff out, but once you know what the circuit looks like, especially if it's something super complicated that you've already simulated in like LT Spice or something, you might as well just go and pay a few dollars to get 5 of these boards.
At work, we go about it a different way. We got a, it's actually like it's a CNC. It's not really like a milling machine per se, but you buy the copper, like a piece of PCB board 2-sided, and it's got copper on both sides. And then you just, using these itty bitty tiny bits, you go and you drill out around the trace just enough to go through the copper, but so you can kind of, you almost mill your circuit out of a piece of copper, but it's a pain in the butt to get rid of the copper in spots where you don't actually want it. You have to like peel it up with an X-Acto.
Yeah.
But for really quick turnarounds, I mean, there's no waiting. You just literally go pop the Gerber in and make it that day. So
yeah, that is kind of the limitation here. I mean, these are being manufactured in China, so the lead times are generally no shorter than a week. So it just depends on what your situation is.
I think so far in our classes, well, at least in the classes I've taken, we've just done breadboards, and I think one of the classes I've taken has done LT Spice, but other than that, we haven't used other programs.
Yeah, so it's just a good tool to learn. It's a good introductory tool. In industry, you might be using a more complex layout tool.
Cadence and Allegro is what we use.
Yeah, Altium Designer, I think, is what SpaceX uses, and Mentor something or another is what Tesla uses. I was working with a company. I was like, oh yeah, how much do you pay for your single license of Altium Designer? And I was like, oh, it's only like $20,000 a year. Like, yay.
Ridiculous.
Only 20,000. Come on, it's just 20,000.
Just got that laying around.
It'll only be worth it if you're making them like PCB every week or something.
Yeah.
Month or whatever.
Complicated stuff. I mean,
Yeah, we just pay $1 million a week.
I'm sure SpaceX makes quite a few different PCBs.
yeah.
Yeah, I'm sure. They probably manufacture them themselves.
For what? Just kidding.
I don't need circuits to go to space.
Rockets or something like that.
What the heck do they do?
Teslas.
Yeah, I'll wrap up on this and hand it back to
They
you.
a diesel company?
Just to remind y'all, we're still recording.
That's true. I can always edit the video.
Yeah.
So as far as you can select a thickness, I think 1.6 is pretty standard. That's the thickness of the fiberglass that the board's made out of. You can also choose a copper weight. We made a motor driver PCB and used 2-ounce copper, if I'm not mistaken.
Yeah, that's right.
higher
Because
conductivity.
yeah, it was a higher power, so the 1 ounce copper wouldn't handle the power; it would have melted the traces. You can either get wider traces or thicker copper, but you can only make a trace that's so wide. So at some point you need a higher copper weight.
Yeah. You can also select the solder mask color. Typically they're green, but you can get red, yellow, blue, white, black. And I think there's, I don't know if they
Get a
charge
black
slightly
one.
more or the shipping's longer or something. 2 more days, but they all look really good. There's nothing like a solid white PCB. The rest of these options aren't super critical. Gold fingers is like, whoops, on stuff like a graphics card. And for, you know, it's just like they'll send you an email. So yeah, nothing too complicated here. You can even, I've never actually had them populate it with surface mount components or anything like that, but generally all the stuff you'll be doing at a hobby level is through hole. I've done surface mount designs before. It's tedious, but it can be worth it. Anyways, handing it back to Jaden.
Yeah, so if you guys want, I can upload the Gerber, see what it looks like. Other than that, I don't know that there's much else to do. I think we exported the right thing. So let me go to, it's actually went to an old.
And you're not screen sharing anymore.
Oh, sorry. Yep.
And you could do the Gerber viewer and just poke around at those and see what you're sending to the manufacturer.
Yeah. So let's see. It actually went into this motor driver folder. I'm just going to do this again. Let's go BASFuzz here. Choose that folder. Okay. Oh, well, okay. That's one way to specify that folder. I'll just regenerate the drill file, generate the map file. Okay, now it should be open here. Just gonna go to this directory, so documents. For some reason it's in classwork. For some reason it's in ENG 250. Oh, actually, look at this. Why is it? Interesting. Okay. This is a bad directory. Don't do this. Oh, this is just terrible. So it ended up in here somehow. Or did it?
It's an example problem.
BASFuzz, NPTH drum.
Example.
Oh, did I go to the wrong thing?
Yeah.
Don't do this. Okay. I don't actually think that was the right thing that we exported.
Yeah,
we have the drill and. Okay, let's go back to this. You don't do this often. So.
You went one directory too far. If you scroll back up to that first page right there.
Oh, plot format. I think maybe I chose the wrong thing. I generated drill file. Okay. What was that even in? That's here. Plot Gerber. Yeah.
You just
plot.
Follow the drill file thing.
Okay, and then this silly directory. And then I think that you zip all of this, if I'm not mistaken. Let me check again.
Files. You can just send the whole package. Like they'll use what they need. And then they'll just send the whole directory.
The whole filter. Okay.
List and everything.
All right. You're gonna have to watch me go through that again when I search for it. Okay. Let's go to layer. All right, here we go. Documents, classwork, ENG 250.
I like how this is like
Okay.
not the first time you're using this directory.
I don't know what happened, man. I'm just gonna open the whole folder. Oh. Control A. Are you sure I don't have to zip it?
Oh, you do have to zip it, but you just zip the whole thing. It's a good way to make
Okay.
sure you don't miss anything.
7-zip. Add to archive. Does it take 7-zip or does it need to be? Okay. I'm trusting you, Cody.
Yeah. And then this nice little previewer, so you can make sure you didn't upload the wrong thing and that everything's there. Make sure the holes are there.
It'll take a minute probably. It's an HTML 3D viewer.
It's really not, the size of your circuit board is really not that bad when you think about it. Like, I guess you don't have the 1/4-inch jacks that you wanted, but it's really just slightly larger than a C battery. It could easily fit inside the housing for stomp pedals, so I think it's not bad.
Well, it's not showing me the preview.
There's that Gerber viewer option. So.
Yeah, I hit that and it made me sign in.
Still thinking.
There you go.
Oh, Lord.
There we go.
I don't know if I can rotate. I don't know what combination of buttons it is.
So
You control
one
click.
question. So do you order all those other things too? With can you order with them?
Like the components?
The resistors.
No, you do that separately. That would be you probably there probably are manufacturers that would do that for you, but it would just be crazy cost because then they have to choose all the components.
Okay, so you just buy them individually.
Mm-hmm.
Yeah, and then you'd go to where Cody was and order. Yeah, I think the minimum is 5, and it's $2 if you're just doing. Oh, that's the motor driver there.
That was more expensive because it had other options, right?
Yeah, and the higher copper weight. Oh, yeah. That was for our sorting machine.
I think I have one of those boards sitting around.
I have mine that's not soldered yet.
Oh, yeah.
Yeah, I did a mistake on that. I flipped one of the terminals. And now I need to desolder that.
Gotcha. Luckily, they're only like $2 and something.
Webcam, you can see it. But I mean, this is a really high quality board. I was surprised for the cost. Like, it is thick, it's sturdy. It's really easy to solder on. Like, the pads don't just come flying off when you solder it. A lot of the cheap perf board I've gotten is way lower quality than this.
They need to pay you as an advertising.
I love JLC PC. It's just good. You could, you'd like never be able to see it, but we did a silk screen with our name on it. We could have done a big logo or something, and there's not a lot of real estate left on this board. The logo text is this tiny stuff right there, and it says our name. It's got Jaden's name on it.
Yeah, you might be able to see on here. No, not really.
The text that Electro-Harmonics leaves on their circuit boards is hilarious. Like, God, for like their big fuzz or something, they put like this Latin quote, nulli de carbonandronum bastardos, don't let the bastards grind you down. Stuff like that. You get really creative that way. Put me back. You see that one happen.
Nice. Yeah, okay. Well, that was all that I wanted to go over, and we hit 8 o'clock. I'm going to stop screen sharing. I don't know how much else we want to talk about today. I think mentioning elections was one thing.
Yeah. Well, as far as like the PCB tutorial, all you would really do to make a formal design that you're really ready to publish is just tune that layout and choose footprints that match components that you buy. So really the process I would do is, you kind of do the design, you could do the layout kind of in parallel with choosing components. Somewhere a retailer like DigiKey will offer footprints with the components. That really simplifies the process. So you just download the footprint, you put it in the library. That's a pretty straightforward process. And then you can order the components at the same time you order the boards. So, you only have one shipping delay. And there's tons of tutorials online, and we're going to keep doing these both as like PDF documents that we're hosting on our Canvas page, as well as additional video tutorials like this. And I think they'll kind of build on each other. I think I'll be doing the next one.
Yeah, and we are planning on printing this board that I just designed right now. But it's probably going to take me another 2 hours or something just to pick out parts and footprints and stuff. I might do that on Zoom if people are interested on like this weekend or something. But I think for our next like official tutorial, it'll be a different design. Maybe Cody will do it.
Yeah, so, and all this PCB design tutorial stuff, we're just using as part of a good guitar pedal design project. So yeah, we're starting with some simple ones. We're going to move into some more complex designs. So yeah, I'll figure out what I'm doing.
Could do it to like delay pedal next. That would be cool.
Yeah.
Yeah, this is probably like the most simple one you could do because it's just blast it through a transistor.
Yeah, highly distorted, kind of like my 330 lab.
Yeah.
Your work is excellent.
And reverb one would be another one. Cool. Reverb. So much things. So good.
How many people had 330 with Esteban?
Your work is
Shit.
incredible.
I love the audio clip that he used for that one lab. Just the whole classroom playing a heavily distorted audio clip. It's great. Yeah, I'm excited to hear your pedal, Jane.
Yeah, we'll see. Maybe it should be good.
What time are you going to work on it this weekend?
Here, yeah, I should decide right now.
Yeah.
Let's see. Let's say Sunday at 2 p.m.
Okay. That sounds good.
Yeah.
I'm with you on that one.
So unsure.
Yeah, feel free just to
Sure,
change
sure.
it a little bit and throw out a email or something.
Yeah.
Not a
Thanks,
show.
Tanner.
Doing the tutorial.
Yeah.
Absolutely.